Welcome back to the deep dive. Today we are cracking open a tiny pale green powerhouse that, often sits on the fringe of the mainstream health discussion, broccoli sprouts.
Right.
You might think we're just talking about salad toppings or maybe some kind of health fad, but we are looking at something far more substantial. We're diving into a body of published, peer-reviewed research that positions these little 3 to 5 day-old seedlings not just as a food, but as, well, one of the most concentrated, naturally occurring activators of your body's own cellular defense systems.
That's absolutely the correct frame for this conversation. I mean, when we compare these young sprouts to their mature counterparts, like the broccoli florets you buy at the store, the sprouts contain anywhere from 10 to a staggering 100 times the concentration of the key precursors.
10 to 100 times.
Yeah, it's an incredible difference. They are essentially a dietary concentrate of power. And our mission today is, it's highly focused. We're cutting through the generalized hype, bypassing the exciting but often misleading animal studies, and looking only at the most rigorous human clinical trials.
The RCTs.
The randomized controlled trials, the meta-analyses. We want to determine with certainty what specific health benefits we can confidently attribute to their key active compound, which is sulforaphane or SFN.
And before we get into the clinical proof, we have to lay the foundation right, because all the benefits we're going to talk about, they all hinge on one critical chemical step happening correctly.
That's it.
It's not just about eating the sprout, it's about making sure this chemical conversion actually happens before or during consumption.
Precisely. The molecular magic starts with a precursor compound called glucoraphanin, or GR. This compound, it exists in really high concentrations in the sprout itself.
Right.
But GR is a relatively inert molecule. It can be absorbed, sure, but sometimes only 5 to 20%. It's not the bioactive punch we're after.
So it's the raw material, but it doesn't do anything on its own.
Exactly. For GR to become the immensely powerful compound, sulforaphane, the molecule that's actually responsible for the detoxification and anti-inflammation, it needs a specific biological catalyst, the enzyme myrosinase.
So GR is the inactive ingredient, and myrosinase is the tool you need to activate it.
Perfect analogy. And nature separates them. Myrosinase is naturally present in the plant cell, but it's physically separated from the glucoraphanin.
Huh. Why?
Well, it's a defense mechanism for the plant. The reaction only happens when the cell wall is physically ruptured by chewing, chopping, processing, or even by certain gut bacteria.
So when the plant is being attacked.
Exactly. When they mix, they react vigorously to create SFN, and this enzymatic step, it is the single most critical rate-limiting factor in determining how effective broccoli sprouts are for you. Get that conversion wrong, and you miss the benefit.
That makes perfect sense. So, okay, let's assume for a minute that we get the conversion right. We're delivering SFN systemically. Can you give us a preview of the strongest evidence? Where does the high-confidence clinical data actually lie?
We can categorize the evidence strength using a standard system, like grade ratings. Our highest confidence, earning a high or even moderate grade, is in the data around detoxification biomarkers.
Okay, detoxification.
We have proven, reliable human trial data showing that SFN consumption enhances the clearing of carcinogens and airborne pollutants from the body. That signal is robust. It's really difficult to ignore.
And what about more general health things that affect daily life?
Well, we have moderate confidence in a second area. Modest but consistent benefits for cardiometabolic health.
Meaning things like blood pressure, cholesterol.
Exactly. Improvements in markers like blood pressure, lipid profiles, and aspects of glycemic control. This is especially true for individuals who are already starting with elevated risk factors. These aren't cures, but they are reliable benefits.
Okay, so then the really big claims, the ones you see all over the internet, like direct human cancer prevention and, dare I say it, human longevity.
And we have to be really clear here. Those claims remain completely unproven in large-scale human trials.
Completely unproven.
Yes. We have incredibly compelling mechanistic data. We know how SFN works on cancer cells in a dish and strong evidence from animal models, but we have zero high-quality, long-term, randomized clinical trials confirming that SFN consumption prevents cancer incidence or extends the human lifespan by years.
That's a crucial distinction.
A necessary one, and we'll come back to it. But for now, we stick to what the human RCTs confirm.
Okay, let's unpack this, starting with essential mechanism that explains everything we just mentioned, the NRF2 pathway. So when we talk about SFN's power, the conversation always leads back to NRF2. For listeners who haven't heard of it, why is this pathway NRF2 considered such a, a big deal for cellular health.
NRF2 is the key. You should think of it as the cell's master switch for defense, or its general contractor for resilience.
The general contractor, I like that.
Every single cell in your body faces daily insults, oxidative stress, toxins, inflammation, and NRF2 is the system designed to clean up the mess and prepare the cell for the next stressor.
So under normal conditions, it's just waiting.
Right. Under normal, non-stressed circumstances, NRF2 doesn't roam free. It is kept tethered in the cytoplasm, the main body of the cell, by a regulatory protein called KEAP1.
So KEAP1 is acting like a sensor, holding NRF2 back until it senses a problem.
Precisely. KEAP1 is constantly sniffing for oxidative stress. You can imagine the KEAP1-NRF2 relationship like a very sensitive smoke detector. KEAP1 is the sensor unit, and NRF2 is the alarm bell that signals the entire house, which is the cell.
And as long as there's no smoke, the alarm is silent.
The alarm is silent. So what sulforaphane does is it forces that smoke detector to sound the alarm, even if the stress is minor.
How does it do that?
Well, SFN is recognized as one of the most potent natural NRF2 activators we know of. When SFN enters the cell, it doesn't just bump into KEAP1, it performs a covalent binding action. It specifically targets and binds to key cysteine residues on the KEAP1 protein.
And that binding is the trigger.
That's the trigger. It causes a conformational change, a change in the shape of KEAP1.
And when KEAP1 changes shape, it can't hold on to NRF2 anymore.
Correct. The tether is released, and once freed, NRF2 rapidly translocates. It doesn't hang out in the cytoplasm.
It has a destination.
It has a very specific destination. It moves directly and purposefully into the cell nucleus, which is, the cell's command center holding all the DNA.
And once it's in the nucleus, what happens? What's the output?
Once inside, NRF2 recognizes and binds to specific DNA sequences known as the antioxidant response element, or R. When it binds to the ARE, it acts like a transcription factor, just throws a switch.
It turns things on.
It turns things on. It initiates the transcription of over 200 different cytoprotective and antioxidant genes. This massive upregulation of defense mechanisms is the functional foundation for almost every benefit we see in the human trials. It's a profound, system-wide upgrade.
Let's talk about the tangible results of flipping that switch. The sources confirm we see a direct activation of what are called phase 2 detoxification enzymes in humans. Why are these enzymes the core evidence that NRF2 is working?
These phase 2 enzymes represent the heavy lifting machinery of cellular detoxification. We have clear, confirmed evidence of their induction, meaning their production is significantly ramped up in accessible human tissue samples.
Like where?
For example, studies examining nasal lavage cells swabbed from your nose, which are often exposed to air pollutants, and gastric biopsies after SFN consumption confirm the dose-dependent upregulation of key enzymes.
Can you walk us through a couple of these? Because the acronyms like GSTM1 and NQO1 can be a little overwhelming.
Absolutely. Let's focus on two classes. First, we have the glutathione S transferases, or GSTs. These include enzymes like GSTM1 and GSTP1. If NRF2 is the general contractor, GSTs are the highly specialized work crews.
Okay, what do they do?
Their job is conjugation. They take potentially toxic, lipid-soluble compounds, carcinogens, environmental toxins, and they physically link them to the body's master antioxidant, glutathione.
And that link does what?
It makes the toxin water-soluble, which marks it for rapid excretion, usually through urine or bile.
So they're basically turning dangerous fat-soluble toxins into harmless water-soluble waste?
Wow.
What about the other ones?
The other key enzyme we see ramped up is NQO1. NQO1's primary function is to directly reduce highly reactive toxic ketones and prevent them from causing DNA damage. You can think of NQO1 as the cellular deactivation specialist.
Neutralizing bombs before they go off.
Exactly. We also see induction of HO1, which plays a major role in regulating oxidative stress and iron levels, further contributing to cellular defense.
The reliance on glutathione seems pretty fundamental here. Is SFN indirectly increasing glutathione, or is it more direct?
Oh, it's a direct and critically important link. The induction of these GST enzymes is so important because they use glutathione. So to meet this demand, SFN directly contributes to creating more of it by upregulating the activity of a specific enzyme, glutamate cysteine ligase. This enzyme is the rate-limiting step in making new glutathione. So by upregulating it, SFN ensures the cell can not only mount a defense, but also produce the necessary ammunition, the glutathione, to power that defense.
So beyond detoxification, SFN also seems to play this dual role by actively addressing inflammation, which is a whole other pathway.
That's the part that really elevates SFN above just a simple antioxidant. It's a powerful anti-inflammatory agent. While NRF2 activation reduces inflammation by cleaning up oxidative stress, a major driver of the fire, SFN, also directly intervenes in the primary pro-inflammatory signaling pathway.
You mean it actively suppresses them?
It actively suppresses the notorious NFKB pathway.
NFKB, often described as the master switch for almost all chronic inflammatory conditions. Why is inhibiting that so important?
Well, the NFKB pathway is what cells use to respond to invaders or injury by launching a strong inflammatory response. In chronic disease, this pathway is often overactive, creating this low-grade, persistent inflammation that damages tissues.
So SFN calms that down.
By inhibiting NFKB's DNA binding activity, SFN effectively dampens the volume of that pro-inflammatory alarm. This reduces the cell's ability to express pro-inflammatory cytokines, the chemical messengers that spread inflammation.
And we have human evidence of this.
Yes. Studies using human immune cells, or PBMCs, have demonstrated a clear reduction in inflammatory markers after exposure to sulforaphane. Specifically, we see reduced levels of highly pro-inflammatory molecules, like IL-6 and TNF-alpha.
So you get a 1-2 punch.
A potent 1-2 punch, boosting the cellular defense system with NRF2 and actively suppressing the most damaging chronic inflammation pathways at the same time.
Here's where it gets really interesting for me, moving beyond just the immediate defense response. You mentioned SFN's unique ability to act on gene expression itself. That suggests it's not just a passing defense, but something that can change the cell's long-term behavior.
Right, now we're talking about epigenetic modulation. This is the study of how behaviors and environment can cause changes that affect the way your genes work without actually changing your DNA sequence.
Okay, so how does SFN do this?
SFN has a unique and powerful ability to influence the physical packaging of your DNA inside the nucleus, which fundamentally determines whether certain genes can be read or expressed.
Give us an analogy for that. DNA packaging sounds pretty abstract.
Okay, imagine your DNA is a massive spool of thread that contains all the building blueprints for the cell. If the thread is wound super tightly onto the spool, the blueprints are inaccessible. The genes are silenced.
And what keeps them wound tight?
The proteins that do that are called histone deacetylases, or HDACs. HDACs are essentially the lock mechanism keeping that thread tightly wound and inaccessible.
So if HDACs are overactive, beneficial genes like tumor suppressor genes could be locked away and silenced.
Exactly. And SFN is a potent HDAC inhibitor. Specifically, research shows it decreases the activity of enzymes like HDAC3 in human blood cells.
And we've seen this in people.
Yes, studies have tracked this effect. HDAC activity was observed to drop in human peripheral blood cells within just 6 to 48 hours after consuming SFN.
So by inhibiting HDAC, what's the net effect?
SFN effectively jams that lock mechanism. By reducing the deacetylase activity, it opens up the chromatin structure. It loosens the grip on that DNA spool. This potentially allows for the expression of beneficial protective genes that might have been otherwise silenced, including tumor suppressor genes.
So it's not just mopping up damage.
No, it's regulating the foundational blueprints and the long-term operating instructions of the cell.
That molecular engine is impressive, but now we have to move to the hard clinical proof, what actually happens in people. You mentioned detoxification has the highest confidence signal. This is where the evidence is clear and consistent.
This represents the strongest data we have, and it provides real-world validation of that NRF2 mechanism. The benefits are best illustrated in large, rigorous randomized controlled trials focusing on populations exposed to measurable levels of pollutants.
And the landmark study for this took place in Qidong, China.
That's the one.
Why Qidong specifically?
Well, Qidong is an area that has been historically exposed to high levels of air pollution, including significant diesel exhaust. This provided a perfect real-world cohort to test whether a dietary intervention could actually increase the excretion of carcinogens that people are breathing in every single day.
Tell us about that trial. What was the intervention?
It was a large 12-week randomized controlled trial with 291 healthy adults.
Yeah.
Participants consumed a carefully formulated broccoli sprout beverage daily.
A beverage, okay.
Yeah, and it was engineered to provide a very specific high dose of the compounds, about 600 micromoles of glucoraphan and some preformed sulforaphane daily. The goal was to test a potent, practical intervention.
And the outcome was measuring how much of these harmful chemicals people were actually peeing out.
Exactly. They measured the levels of metabolized carcinogens excreted in the participants' urine, and the results were rapid starting within hours and sustained through the entire 12 weeks.
What were the key pollutants they tracked, and how big was the effect?
They focused on key airborne toxins. They observed a massive 61% higher excretion of benzene mercapturic acids and a 23% higher excretion of acrolein conjugates.
61% for benzene. And benzene is a known carcinogen, right? From car exhaust and things like that.
A well-known human carcinogen. Acrolein is another potent carcinogen found in smoke, like tobacco and cooking smoke.
A 61% increase in carcinogen elimination is extraordinary for a simple dietary intervention. It proves that those phase 2 detoxification enzymes are really working hard.
It anchors the entire discussion. It confirms SFN isn't just theoretically boosting these pathways. It is actively, measurably enhancing the elimination of these harmful compounds from the human body.
And they even figured out a minimum effective dose from this, right?
Yes, a subsequent analysis on the data established that to get significant benzene detoxification, participants needed to excrete approximately 25 micromoles of sulforaphane metabolites per day.
So there's a threshold.
There's a threshold. If the dose was too low, the detoxification benefits were statistically non-significant. And this is hugely important because it sets the minimum bar for what an effective daily dose is if detoxification is your main goal.
Okay, moving on to the metabolic side of things, cardiometabolic health. The evidence here you graded as moderate, so a reliable benefit, but maybe not as dramatic.
That's the right way to frame it. Reliable, but modest. We have several high-quality meta-analyses that synthesize data from many smaller RCTs, and they point to consistent effects, especially in populations with elevated risk factors. The clearest signal is for blood pressure.
What kind of numbers are we talking about for blood pressure?
The pooled analysis from multiple trials showed a modest but consistent reduction in systolic BP of about -5.11 mmHg and a reduction in diastolic BP of -3.36 mmHg.
Which, to give that some context, is pretty significant for a lifestyle change.
It is. It's often comparable to what you'd achieve from a moderate, sustained intervention, like adding regular exercise or seriously cutting back on salt. It's not the same as a prescription drug, but for someone who's pre-hypertensive, this is a highly valuable, reliable intervention.
And it seems the benefits were more concentrated in certain groups.
Yes, and that's a key detail. The greater effects were consistently seen in individuals who were already hypertensive or overweight or had other existing risk factors. It wasn't as pronounced in perfectly healthy young adults.
Which makes sense. It's helping to correct a dysregulated system.
Exactly. It's pushing the system back toward homeostasis.
And turning to type 2 diabetes, we see improvements not just in blood sugar, but also in the associated risks.
The clinical studies here, usually short-term RCTs of 4 to 12 weeks, show strong signals. One common protocol used 10 grams of standardized broccoli sprout powder per day.
And what did that do?
It showed measurable improvements in lipid profiles in patients with type 2 diabetes. Specifically, researchers saw significant reductions in triglycerides and, crucially, a better oxidized LDL to LDL ratio.
Why is that oxidized LDL ratio so important?
Because LDL cholesterol is only really dangerous once it becomes oxidized. That's what leads to plaque formation and atherosclerosis. By reducing that ratio, SFN is helping reduce one of the most critical markers for cardiovascular disease risk, which is a huge issue for diabetic patients.
But the benefit goes deeper than just lipids, right? It hits the core problem of insulin resistance.
Exactly. The same intervention also resulted in improvements in the central markers of glycemic control. They saw meaningful reductions in fasting glucose, and maybe even more importantly, reduced HOMA-IR.
And HOMA-IR is the gold standard for measuring insulin resistance.
It is. A reduction in HOMA-IR is the best way to show improved insulin sensitivity across the whole body.
So how does SFN, a detox agent, actually do that? What's the mechanism?
Well, it loops right back to NRF2 activation, but this time in the liver. In type 2 diabetes, the liver often makes too much glucose, a process called hepatic gluconeogenesis.
Right.
NRF2 activation, driven by SFN, seems to inhibit the key enzymes involved in this overproduction. So by reducing the liver's unnecessary glucose output, SFN helps bring overall blood sugar levels down and improves the body's glucose management.
Okay, finally, in this section, let's look at liver biomarkers. This is an area with some of the longer-term human data we have.
The evidence here is graded low to moderate, but it's valuable because it comes from a longer 24-week RCT, which is pretty rare in this field. The trial focused on middle-aged adults who had high normal liver biomarkers.
So a group that's at risk for liver stress, like fatty liver disease.
Exactly, that's the cohort.
Yeah.
They were likely experiencing significant liver stress.
What was the intervention and the outcome?
Participants consumed a glucoraphanin capsule supplement for 24 weeks, and the result was a significant improvement in serum ALT.
Alanine aminotransferase?
Right. Elevated ALT is one of the main clinical indicators of liver damage or inflammation. The improvement is mechanistically linked to SFN's ability to powerfully induce those phase 2 enzymes, enhancing the liver's natural capacity to neutralize toxins and reduce the overall stress on the liver tissue.
Moving to neurobiology and mental well-being, the most compelling, though still heavily nuanced, human trial data is around autism spectrum disorder, or ASD. This is a complex area, so we need to be careful here.
That careful approach is essential. The landmark trial was the Singh et al. RCT from 2014. It was a meticulously designed, double-blind, placebo-controlled study, and they enrolled a very specific cohort.
Who were they studying?
Young men aged 13 to 27 who had been clinically diagnosed with moderate to severe ASD.
And what was the dosage protocol?
The intervention involved administering standardized sulforaphane from a broccoli sprout extract daily for 18 weeks. The dosing was titrated based on body weight, ranging from 50 to 150 micromoles of SFN equivalent.
So a therapeutic dose. And what were the key outcomes?
The results in this initial trial were remarkable. They generated a lot of excitement. Compared to the placebo group, the SFN group showed large and statistically significant improvements. Specifically, they saw about a 34% reduction on the Aberrant Behavior Checklist, or ABC, scores.
Which measures things like irritability, hyperactivity.
Exactly. Irritability, lethargy, hyperactivity, stereotypy. They also saw significant improvements on the Social Responsiveness Scale, the SRS, which tracks communication and social interaction skills.
So caregivers and clinicians were observing real, noticeable improvements.
Yes. On the Clinical Global Impression Improvement Scale, which measures overall function, significantly more participants receiving SFN showed improvement in social interaction, abnormal behavior, and verbal communication compared to the placebo.
That sounds incredibly promising, but there was a critical piece of information that came out after the treatment stopped.
Yes, and this is the detail that concerns the mechanism is treatment-dependent. The improvements were not a permanent change. As soon as the SFN supplementation was stopped, the scores rapidly returned toward baseline, often within 4 weeks.
So it's actively suppressing symptoms, not curing the condition.
Precisely. It suggests SFN was correcting an underlying biological imbalance, but only while it was present in the system.
So what are the working theories for the mechanism here? How does an antioxidant and detoxification agent impact complex neurodevelopmental behavior?
We circle back to the core pathology of ASD. It's frequently associated with underlying biological issues, notably chronic, elevated oxidative stress, neuroinflammation, and mitochondrial dysfunction. SFN, through NRF2 activation, directly addresses all three of these areas.
And there's a more specific hypothesis involving heat shock proteins, right?
Correct. One highly compelling hypothesis involves the induction of heat shock proteins, specifically HSP70 and HSP90. These proteins are named because their production ramps up in response to stress, including heat exposure, but also oxidative stress and inflammation.
And what do they do?
They're critical molecular chaperones. They help maintain cellular homeostasis, ensure other proteins fold correctly, clear out damaged proteins, and protect mitochondrial health.
So the idea is SFN might be mimicking the temporary benefits sometimes seen in ASD patients during a high fever.
That's the hypothesis. This induction could potentially restore some crucial cellular balance that had been disrupted by stress and inflammation, leading to the observed improvements.
But now we have to address the replication challenge, which is why the evidence is graded low to moderate.
We must be transparent about this. Subsequent, similar trials did not yield the same success.
So they didn't replicate the results.
The Bent et al. Trial in 2018, for example, did not replicate the significant effects. This failure led to a necessary downgrading of the confidence level. Reproducibility is paramount in science.
So why the difference? What do researchers think happened?
Well, if you look closely at the cohorts, there are several differences. The negative replication trial generally involved significantly younger cohorts and potentially individuals with milder baseline severity.
So it might be more effective in a specific subgroup.
It's hypothesized that SFN may be more effective in individuals whose ASD symptoms are more strongly correlated with high levels of oxidative stress and inflammation, which tends to be more prevalent in the moderate to severe older cohort studied by Singh.
Interesting. Okay, moving outside of ASD, there are some other preliminary signals in mental health, particularly for conditions like schizophrenia.
The evidence here is low, but the mechanistic link is intriguing. Schizophrenia is often associated with dysregulated glutathione metabolism and oxidative stress in the brain.
And what have the trials shown?
Meta-analyses of SFN intervention trials have shown a modest improvement in negative symptoms, things like social withdrawal or reduced emotional expression at the 12-week mark. But crucially, these improvements were often not sustained long-term, and there was no evidence for improvement in positive symptoms like hallucinations.
But the mechanism again relies on SFN's antioxidant power in the brain.
Correct. And the most interesting piece of evidence supporting this comes from advanced imaging. Spectroscopy studies confirmed a measurable increase in glutathione levels, our master antioxidant, in the brain tissue of participants who received SFN,
How much of an increase?
up to a 19% increase in this vital defense molecule. This strongly suggests SFN is boosting the brain's own defense systems.
Okay, before we transition, let's circle back and address the most popular and often overstated claims: longevity and cancer prevention. We need to be crystal clear on the limitations here.
This is where the informed listener needs to draw a hard line. The evidence base here for human clinical outcomes is graded as very low. We have to separate preclinical potential from clinical proof.
So the lab data is strong.
Exceptionally strong. SFN shows powerful promise in reducing tumor growth, initiating cell death in cancer lines, and even extending lifespan in simple organisms and some rodents.
But the human translation is still missing.
Critically missing. No high-quality, long-term human randomized controlled trials confirm that SFN supplementation prevents cancer incidence or extends human lifespan. Cancer prevention trials require massive cohorts and decades of follow-up.
So the observational data linking cruciferous vegetable intake to lower cancer risk isn't enough.
It's a highly indirect association. It includes all compounds in those vegetables and isn't specific evidence for isolated SFN. Until the hard human data exists, we cannot make therapeutic claims about cancer prevention or longevity.
Okay, we've established that SFN is a proven activator of NRF2 with confirmed benefits in detox and promising signals elsewhere. But all of this hinges on one actionable truth. You have to generate the active SFN molecule and get it into your bloodstream. This brings us to the most practical section, the preparation paradox.
This is the critical juncture. If you're going to invest the time and money in consuming sprouts, you have to master the conversion step. If you fail the conversion, the sprouts are essentially just a source of fiber and vitamins. You miss the big benefits.
And it all comes back to that conversion crisis glucoraphanin and relying entirely on myrosinase.
Exactly. And the numbers that illustrate this are quite dramatic.
What are we talking about?
We know from bioavailability studies that when SFN is administered directly, so the conversion has already happened, it is approximately 6 to 7 times more bioavailable, with absorption rates around 70%.
70%. That's high.
Very high. In contrast, if you rely solely on glucoraphanin with no active myrosinase, say you overcook them, the absorption often drops drastically, sometimes below 20%, even as low as 5%.
5% versus 70, that's a huge difference.
That's the difference between a therapeutic dose and virtually no benefit at all.
And the natural tendency when preparing food is to cook it, but with sprouts, that's the single worst thing you can do.
That is the preparation paradox. High heat processing, boiling, high heat steaming, pasteurization, destroys the heat labile myrosinase enzyme. If that enzyme is inactivated, the conversion of GR to SFN just stalls.
So if I want to eat my broccoli sprouts in a hot soup or something, what's my simple bulletproof mitigation strategy?
You have to introduce a source of exogenous heat-stable myrosinase. This is what we call the mustard seed synergy.
The mustard seed synergy.
Adding a tiny pint, even a quarter teaspoon of raw mustard seed powder or daikon radish shavings to your cooked sprouts can completely restore the conversion efficiency. The myrosinase in mustard seeds is far more stable than the enzyme in the broccoli plant itself.
So it just reactivates the conversion.
It reactivates the conversion reaction on the cooked glucoraphanin, maximizing your SFN yield.
That is genuinely actionable knowledge. Now, if I'm eating fresh sprouts, what are the evidence-based techniques to maximize the yield?
The foundational rule is raw consumption and thorough mechanical disruption, which really just means chewing.
Chewing is critical.
Chewing is critical because it physically ruptures the cell walls, ensuring the maximum mix of GR and myrosinase occurs right in your mouth. Studies show thorough chewing significantly increases bioavailability.
And then there is this counterintuitive, gentle heat hack.
Yes, this involves the epithelial-specifier protein, or ESP. This is where we get into the advanced chemistry of the sprout. Inside the plant, ESP acts as a competitor, a decoy protein.
A decoy?
Instead of directing the conversion toward forming the active SFN molecule, ESP directs it toward forming inactive compounds called nitriles. And nitriles provide no benefit to you.
So the sprout is actively trying to prevent the maximum SFN yield.
Exactly. But researchers discovered the gentle heat hack. Research has shown that heating sprouts briefly for, say, 10 minutes at a very specific low-temperature range of $70 or 158 to 7 may selectively inactivate this ESP decoy protein,
While preserving the myrosinase.
while preserving the crucial heat labile myrosinase enzyme. By inactivating ESP, you remove the competitive pathway, potentially increasing the overall yield of the active SFN molecule substantially.
That is incredible. What about timing? Does when I eat them matter?
Yes. For maximum sustained biological effect, studies show that split dosing is superior to a single large dose. SFN metabolites are cleared from the body relatively quickly.
So 2 smaller doses are better than 1 big one.
Right. Administering, say, 100 micromoles twice a day, roughly 12 hours apart, sustains higher and more consistent plasma SFN levels over a 24-hour period than one massive 200 micromole dose.
But even if 2 people followed the exact same protocol, their results might vary wildly. Why is that?
That introduces individual variability, and it comes down primarily to their internal ecology. The gut microbiome.
The gut bacteria.
Gut bacteria, specifically some species, can perform a variable conversion of GR into SFN, especially when the plant's own myrosinase has been destroyed.
So my gut bacteria determine my response to, say, overcooked broccoli.
That's precisely right, and research is getting specific. In prediabetes trials, they found the abundance of the bacteroids Fragilis BT2160 operon in the gut microbiome was a strong predictor of an individual's glycemic response to the sprout intervention. Your personal microbial fingerprint can dictate how much SFN you generate internally.
Are there genetic factors at play too?
Yes, specifically genetics related to those phase 2 detox enzymes. Individuals who are GSTM1 null, meaning they lack a functional copy of the GSTM1 gene, may show slightly higher plasma SFN levels.
Why is that?
The hypothesis is that because SFN is conjugated for excretion by these enzymes, if you lack one version, SFN may stay in circulation slightly longer. But these differences aren't currently used for personalized dosing.
Okay, let's translate all these micromoles and genetics into something actionable. What are the required daily consumption numbers?
Based on the reliable clinical trials, the typical effective range for SFN equivalent daily intake is generally 50 to 150 picmoles SFN daily.
And how does that translate into raw sprouts I can buy at the store?
This depends a bit on the age and quality of your sprouts, but for fresh, 3 to 5 day old sprouts, this translates to approximately 20 grams. A small handful to 60 grams, about 3/4 of a cup of fresh, raw, and thoroughly chewed sprouts daily.
So a small handful to a cup.
Right. If you're targeting the heavy detoxification benefits, you might push toward the higher end, but 20 to 60 grams is the sweet spot for general metabolic enhancement, and you must follow the preparation rules to hit that range.
With any potent bioactive compound, safety is paramount. When we look across the trials, how does the SFN safety profile hold up?
The safety profile is excellent. It supports its GRAS status, generally recognized as safe. Sulforaphane has been remarkably well tolerated in clinical trials, up to 400 bolitexmol a day, which is significantly higher than the therapeutic range we discussed.
And the side effects are minor.
The side effects are mild and almost exclusively gastrointestinal, things like flatulence, mild GI discomfort, and a strong bitter taste. Importantly, in most trials, the incidence of these mild events was similar between the SFN group and the placebo group.
So nothing serious.
No serious adverse events were reported in the vast majority of RCTs up to 18 weeks.
Are there any specific medication interactions or populations that need to be careful?
Yes, 2 key medication cautions and 1 major physical safety caution. First, if you are currently taking anticoagulants, particularly warfarin, you must use caution and consult your clinician.
Because it could thin the blood more.
It could potentially augment the blood thinning effects. The advice is to be consistent with your intake and monitor carefully.
And what about interactions with other common drugs?
SFN is known to influence the activity of the liver's CYP450 enzyme family, which metabolizes a huge range of prescription drugs, from statins to antidepressants.
So it could change how those drugs work.
It could theoretically speed up or slow down the metabolism. While clinically significant interactions in humans aren't well documented, caution is absolutely warranted, especially with drugs that have a narrow therapeutic window. You should always inform your healthcare provider.
And finally, that physical safety caution about the sprouts themselves.
This is a non-negotiable health warning. Because sprouts are grown in warm, humid conditions, they are susceptible to bacterial growth. Outbreaks involving Salmonella and pathogenic E. coli are a real risk.
So certain people should avoid raw sprouts.
It is strongly advised that immunocompromised individuals, the elderly, children, and pregnant women, should strictly avoid consuming raw sprouts. If these individuals want to consume them, they must be processed with a heat method to ensure the bacteria are killed.
Looking forward, what are the biggest gaps in the research that prevent us from making even stronger recommendations?
The primary gap remains the lack of scale and duration of the trials. We desperately need massive, long-term RCT studies lasting longer than 1 or 2 years to test hard clinical endpoints.
So we know it improves biomarkers, but we don't know if it prevents heart attacks or cancer.
Exactly. The medical community needs trials to see if improving blood pressure and cholesterol translates into an actual reduction in major disease incidence.
And what about delivery and formulation? Are supplements standardized enough?
No, not yet. The industry needs rigorous head-to-head trials comparing fresh, properly prepared sprouts versus standardized extracts with verified active myrosinase content. The current heterogeneity of commercial products complicates our ability to give universal dosing advice.
Finally, you mentioned individual variability, genetics, and gut bacteria.
Future research needs to embrace personalization. We need trials across diverse ethnicities, ages, and sexes, and we need studies that actively stratify participants by their genetic markers, like GSTM1 status, and by their specific microbiome phenotype. This will help us understand who truly benefits most.
So what does this all mean? We've seen powerful proof that SFN works to activate our internal defense systems and clear toxins, but we don't have the final proof of decades-long benefits.
The provocative thought is this. SFN is arguably the ultimate cellular system booster, and the evidence supports its role in enhancing health span. The data confirms SFN is highly effective at boosting NRF2, clearing measurable carcinogens, fighting inflammation, and regulating metabolism. It makes your internal defense and cleanup systems run optimally.
And it's plausible that running those systems optimally will extend lifespan.
Highly plausible. But we simply lack the long-term human outcome data to definitively prove that increasing our defense systems translates into decades of increased longevity. It's a proven tool for the quality of your life today, with strong theoretical backing for a longer tomorrow.
That makes the sprout a powerful tool right now, even without the final word.
Absolutely. The evidence strongly supports broccoli sprouts as a highly potent tool for detoxification and metabolic support, provided you get the chemistry and the preparation right.
Our final actionable takeaway for you is simple. If you are going to invest the time and effort in consuming sprouts or sprout powders, you must ensure maximum conversion. Consider the simple but powerful mustard seed synergy, adding a pinch of raw mustard powder to maximize your sulforaphane intake, especially if you apply any heat to them.
Get the enzyme. Get the benefit.
Thank you for joining us for this deep dive into the NRF2 activation code.